I'll just go through the slides, not the slides what you got. I have created a summarized one, like what you have in which week, and I'll just show you the things you can focus on, right? So let me go. You can see, no, my screen. It's
Yes, sir.
visible. Okay. Okay. So from week one, we don't have much thing. So it starts with what are modules. This is little important. Identify the type of clients like external, internal, or other software. Okay, so these are the phases. We have the brief of the phases, like what are the software engineering process, right? The requirement, design, test, development, testing, maintenance, what is what. So few things. And this is the main focus of the week one, that different models, right? So waterfall, prototype, and spiral, these three models along with agile, right? So four. So you need to check for the advantage and disadvantages for the models. That's the key focus on this particular chapter, where I should go for which kind of model, right? And for the agile portion, these terms are very important. Please try to find out the definition of the term and what are the role of what, right? So those things has to be very clear. So what are the terms? The terms from the agile side, because in agile you won't get a numerical question or a kind of a scenario based question. It will be straightforward kind of with some term, like what is what. Okay, this is about the week. So key focus will be this model, right? What are these four models? Three models here and along with the agile. So this is about the week one. Okay, let me go for the week two. Okay, week two, we are having the requirement gathering and analysis. Again, the type of your users. So identifying the type of the users, right? And requirement, like why it is ambiguous, why it is inconsistent, why it is incomplete. So you can get those kind of question in the graded, or so please practice with that. It will be very similar to the whatever the questions you have given. Scenario will be different, but ultimately it comes to the same thing. This is an important portion, like when I should use which kind of technique, right? So question here, right? Whenever I'm having a huge client base, whenever have to get a survey from a large amount of people, right? It's good. So interval will be good whenever I want to find out what are the difficulty faced by my users with the existing system. Then we are having focus group workshops. So which are better whenever we want to find out some common agreement with the people, some we want to reach some consensus, right? Then we are having these observations, right, where we basically check out in real business how it basically works. And finally, we are having the starting documentation, which is basically formulating some rules, regulations, standards, etc. Right? Now, identifying something as a functional and non-functional requirement. Okay. Now, we are having SRS. So you need to know what is the requirement of SRS, why we should use. So you may avoid detailing of the SRS, like which portion, what is that. So that you can find out. We haven't put also question on the graded or activity, but what is the advantage of a SRS, why we should use, those should be known. Okay. So this is the behavior driven design. This is for the agile process, right? So where this user story, again, very, very important part. So please practice all the user story based questions from the graded as well as from the activity, like how to identify which is user, which is action, which is the benefit, and identify these things, the smart requirement, right? Smart characteristic of the user stories. So suppose I find a particular action is not achievable within a particular time, so I break it into two pieces, into user stories. So that's basically I'm making it achievable. I say something will be reached, done in a reasonable time, which is not measurable. So I want to quantify. I say it will be done by 1 month, right? Something like that. So we'll give some scenarios like that. And we have done a lot like in the graded, as well as there are a lot of questions in the activity. Please go through those things. But this portion is very important. Okay. So main focus will be this slide, right? The SMART criteria. I'm not saying rest are not important, but you should focus on two things. One is this, right? Requirement gathering technique and the SMART, the characteristics of good user stories. Okay. Week 3. So it's basically the prototype designing and evaluation of the prototype we have, right? So this is the step to create a prototype and evaluate a prototype. This is the usability goal, right? So this is again very, very important, right? Please note it down. You have to check out like what is what. So we'll give certain scenario. So you have to say which usability goal is achieved by this particular thing. So type of prototyping technique. So it's a paper prototyping or some other kind of prototyping. So this figure you have to check out. It's there on the slide. It is there on the video also. Please go through this. Okay, now this is the evaluation of prototype. This is again very, very important, right? So the criteria are this consistency, use of familiar language, metaphor, clean and functional design, freedom, flexibility, recognize over recall, show status, prevent error, support error recovery, provide help. So few things are little having overlap. So please go through very clearly. Like sometimes this support error recovery, prevent error recovery and provide help. It's very difficult to understand which is what. So please go through properly, like whatever the question, and try to find it out. If you have still some doubt about the question, you want to have an understanding, but post it on the discourse will help it out. Okay. So again, the key focus will be this evaluation, right? And this is usability goal. Okay, so week 4. This is very, very important chapter, say week, you rather say. So in this week, first is the responsibility of a software manager. As it's project manager basically, right? I don't know which term you have used. It should be a project manager. I don't know in the slide it's a software manager or project manager. It is written. So now how we measure the code, right? The size of the code is measured in KLOC. Please remember it. It's not a LOC, KLOC. And effort is person month. And type of estimations are empirical or heuristic. Empirical could be expert judgment, where we call certain expert and say what will be the cost of my project. So he uses his experience to just make a educated guess, right? But there could be some bias, right? One person is just guessing out. So the better will be we can have a group of experts. But much better approach is Delphi. So where we'll have many experts, stakeholders together, and there will be a coordinator, right? So there will be exchange of the ideas and all, and it's evolved like what could be the estimation. Heuristic model, it's basically a mathematical based model. So we say it's a COCOMO model, right? So here you can definitely get some kind of numerical, right? So please, there is a numerical in graded and there is another numerical which is there in the AQ. So please practice with both the things, right? And identifying a scenario which is organic, which is semi-detached and which is embedded. That's very important because we won't be telling it is directly like it's a semi-detached or what kind of project. We'll give you the scenario, right? So organic means you are having people with the experience. It's a small group and tasks is also less. Semi-detached means you are having a mix of people, experience and new people, right? And embedded means the project is very difficult project, and it's basically having some kind of hardware. It's a software along with some hardware, which is a embedded project. So you need to find out certain clue in the question to find out what kind of project is. Then it's a direct formula, right? There is a formula where you have the value of a and b, and it's basically something like a plus something to the power b to calculate the thing. So please practice with the problem here, right? So there will be two questions you can find. One will be on the graded, one will be in the activity. Please practice with both the questions. Next is project breakdown activities. So where you will have the activity network and NAT chart. So activity NAT chart based question, both are there in the graded assignment. Please practice with them. Very important thing, this scenario based question to find out what kind of risk it is and how we can mitigate. So these scenario based questions are there with the common data. You can find them in both in the activity question as well as in the graded question. Please practice with all the questions and also find out whatever there in the slide. Not this slide. This slide I have just given some pointers. In actual slide, you can find out this is the problem and this is the mitigation of the risk, right? Please try to practice with those, all those things. There could be a small problem with risk assessment. Just remember the formula, how to do it, because it's very simple to do. Again, from the Agile, as I told, the terms and what is the role. So what is the role of a development team? What is the role of the product owner? What is the role of this Scrum Master? These are the very important thing. So what do we do actually in the sprint planning, and who is responsible to do this planning? So these questions are this kind. So it's basically a theoretical based question, and it will be from the slides from the Agile. But these terms are very, very important, right? So please go through the slides for this theoretical based questions. For theoretical based question, you may not depend on the graded or activity because they are directly from the slides, right? It could be anything. But scenario based or the numerical based, they will be similar to what is there in the what we have done in the graded and in the but it could be it's definitely it's a different scenario. It's not the same scenario. Just 1 minute. What happened? Okay. Now week 5, it's again designing. So requirement, prototyping, then designing. So for requirement, there are two basically weeks are there. First week is like a traditional approach, right? Which is SRS based approach. The second is the agile approach, which is basically the user story based approach, right? The week, this week is a week 5 is on the software design, right? So in designing, you need to understand like designing all about identifying or segregating the entire project into components and find out how the components will interact with each other and how internally we build the component, like deciding what will be the data structure or data and what will be the algorithm or functionalities, right? How we'll build all those things. Now, it's entirely focused on two terms, this coupling and cohesion. So please try to understand what is coupling and cohesion. So coupling is all about its measurement of the dependency between two modules, right? How strong it is or how weak it is. So if two models has to interact a lot to do a particular work, so they are having high dependency. If they don't have to interact much, then they are having a low dependency. So low coupling is always better, low dependency, because if you have a high coupling, if you change one module, that changes also has to be made in another module, right? So the changes cannot be done on isolation in a module. So that's the That's why the low coupling is always good. But cohesion is measurement how your functions within a module focused on doing a single thing. Right? All basically take part in a single object. So high cohesion means they are really focused on single objective. Low means they are not focused. So high cohesion is better. So please find it out. This is important. Type of coupling as well as type of cohesion. So data coupling, it's just parameter passing some integer values, passing some string. Control coupling is something like you pass a parameter through which the control flow will be decided in another module. So inside a module, there is a switch statement, but the particular flag, we send it from another module which decide which case will be executed. So I'll pass a value from one module which will decide what will be the flow in the second module. Right? That's a control coupling. Common coupling means your modules are sharing a common data structure or common data, global data, right? Content coupling, a particular module is referring internal of another module. Okay, similarly, there are cohesions, type of cohesions, please go through this also. So functional cohesions, as we discuss, all the functions are focusing on a single object. Sequential cohesion, so basically functions are arranged in a sequence. So output of one function taken as a output, output of one function taken as an input to the next function, and they are going to be part of a single objective. But procedural cohesion is just a little different. The functions are arranged in a sequence, but they do not contribute to the same objective. They basically contribute to some different objective. Communication cohesion, all the functions of the module refers to or update to the same data structure. They only collaborate to the same data structure. And last is coincidental cohesion. Because they do not have a meaningful objective, right? They are put together, but they do something different. Then we go for the object orientation. In object orientation, these relations are very, very important. If you have solved the graded assignments and these things, there are two kind of questions you could check out. One is we give a scenario and ask you, is it an association, is it a composition, or integration? It's a inheritance or it's a dependency, right? And second question, we give a figure, right? A class diagram, and ask you, okay, find out what kind of class relation we have. So we need to prepare with both kind of things, right? So association, it's a interaction between the class by calling some function. Say I'm having an author class, there is a book class, so author writes a book, right? So they're collaborating through a function. Composition, it's an aggregation of something or it's a composition of something. I say a computer made of RAM, hard disks, processor, etc., or a car made of tire, engine, something. So it's a composition. Inheritance, it's basically is a clause. If you have done Java, you have done a lot. We say employee is a manager, so employees are inherited. And last, we have a dependency. Whenever change in one class enforce the change also has to be done on the another class. It's basically could be achieved through it is the highest kind of dependency could be achieved through an interface and implementation of that interface, right? So if you make a small change in a function in the interface, since the functions are abstract functions, right, the same changes also has to be done in the implementation class. Even inside interface, suppose you add an abstract method, so same abstract method also has to be implemented in the implementing class, right? So change in one enforce changes in another. So that's basically the dependency. So this is the way we identify. Now these are basically part of class diagram, whatever we have discussed over here. But whenever we are having number of classes and we want to find out some kind of modeling of a scenario. We want to represent a design using it. So we go for some kind of tool, which is called as a UML tool, right? So UML basically means it's a language it's a pictorial language through which will represent a design. So which could be a structural type or could be a dynamic type. Structural, we have already seen, it's a class diagram. We'll have the class and their interaction, right? And there could be a dynamic behavior. We show the flow of the interactions, right? So it could be a state machine, it could be an activity, or it could be an interaction. Inside interaction, we have learned the sequence diagram. So there was a question in the graded on the sequence diagram. You can just glance through once. But most of the focus will be on the class diagram and identifying all these things, right? The class relation and the class diagram will be main focus. Along with these two, the type of coupling, type of cohesion, and understanding this coupling and cohesion. What is coupling? The coupling should be high, low, cohesion should be high or low, this kind of. Week 6 is not there. Okay, week 7. Week 7, we don't have a lot of things. There are limited things and you can complete it very fast. So we are having the development environment. There are tools. Please remember few of the tools, like which tool could be used for writing a code, which could be used for debugging, which could be which kind of software, sorry, not code, could be useful for which is used as IDE, right? Which is used for debugging, which is used for version controlling. Git, right? The functionality of Git questions, the functionality of Git. So please go through all the question form for Git. So we don't have much thing here to understand because it's very straightforward, but this slide is very important. Okay, whatever is there, the technique for debugging. So this is very important, and strategies for debugging. So these two things will be key focus here, along with the Git. Okay, these three also, the complexity of our program, right? It could be cyclomatic complexity, or it could be using LOC, KLOC, or using this health state methods. Okay, so at the end we have the code smell, which is quite easy. You can just glance through once. So what are code smell? These are basically the problematic characteristics of a code, right? So you can just glance through it once. It's not difficult at all. Okay, now week 8 is a bit difficult one, and I'll suggest you go through the slides, go through the video if possible once again. Okay, first we start with the software architecture. This thing mostly, if you know, because most of the thing you have covered in AppDev. So it's a client server kind of architecture, pipe filter. This is kind of no. So it's this model view controller, peer-to-peer architecture. So most of the thing you know. But this is very important, right? Solid principle. Please go through it very carefully, because this needs a very clear understanding. If you require a particular part of it, I can discuss, but it will take a lot of time to discuss everything. So I won't be discussing here right now. But if you have some kind of problem, you can tell me now, or you can also ask the question. Or maybe like quickly, if you want to have a session, like mid-based session, we can also have that if you have very urgent kind of. So design pattern, whatever we have, creational. So this is about how objects should be instantiated. We have seen factory and builder, right? Form structural. So that's mostly how the classes will interact. We have facet, adapter, and for the behavioral, right? So these are the things we have. Next, I tried to put some pointer to the things. So if you record, I'll discuss. Otherwise, it's maybe I'll go back and try to find out what are your doubt. But just as a summary, like we'll be having around 25 questions. There will be questions which will be directly from the slides, which will be directly from the lectures. But most of the questions will be the scenario-based question as we have encountered in the graded assignments. My suggestion will be always go through the activity questions also, because they are also mostly on the same level, and there will be one or two numerical questions, right? Yes, from your side, anything?
Sir, anything will be descriptive type?
No descriptive, like you don't have to write any subjective answer.
Oh,
There could be answer like some number. If there is a problem, you may have to enter some number, but there won't be any.
okay, sir.
Anything else? Okay, then if you don't have, shall we close? Okay, I don't think anybody. Yeah, Dibyendu, anything?
No, sir, nothing.
Okay, then thank you all. Thank you for
Thank you.
participating
Bye.
today. Bye.
Thank you, sir.